Do you work near or around stored or produced hazardous CO2? Meet the RAD 01026 Remote CO2 Storage Safety 3 Alarm, your indoor CO2 safety solution. Feel safe and secure in knowing your staff, employees, and establishment are all protected when it comes to working near hazardous gas. Don't wait until it's too late. Shop the RAD 01026 Remote CO2 Storage Safety 3 Alarm today at www.co2meter.com.
Hello and welcome to HGView Webinars with me, Rob Cockerell.
And me, Thomas D. With pilot projects underway and technology proving its potential, the electrolyser industry is on the brink of a major transformation. But with 2030 and 2040 fast approaching, the path to large-scale deployment is still filled with challenges. So just how can the industry overcome these hurdles and ensure that electrolyser technology is ready to meet the growing demand for green hydrogen?
And that is what we set out to discuss today in this exclusive HGView webinar sponsored by CO2 Meter. Over the course of the next hour or so, we'll explore the critical challenges and opportunities in the electrolyser sector, from technology assurance to supply chain readiness. Our expert panel will explore how the industry can scale up to deliver on the promise of a hydrogen-powered future.
And you, the viewer, will also have your chance to get your questions answered during our live audience Q&A near the end of the webinar. So if you have a question or one comes to mind at any point, then please do send it in and we'll do our best to get it answered.
Yes, please do. And to get this webinar underway now is our first expert speaker of the day, Jonathan Long, Senior Consultant at ERM. John started his career at Air Products, holding roles in project management, plant operations and process engineering design for industrial gas facilities, and worked on the NEOM green hydrogen projects and green ammonia cracking plants. At ERM, he specialises in electrolysers and sits in the hydrogen and fuel cells team, where he works on market studies, technology assessments, feasibility studies and technical due diligence for projects covering production, transport and storage of hydrogen.
Welcome to the webinar, John. It's great to have you on. Let's set the scene a bit here and get a feel on the current state of play within the hydrogen industry. So what can you tell us about electrolytic demand for hydrogen, both currently and going into the future?
Yeah, thanks for the introduction. It's really good to be here on this conversation for sure. So in terms of demand now, I think briefly for context, if we can just set the scene with the context, the overwhelming majority of current hydrogen demand is from existing industry and refining demands, which is virtually all met by fossil-derived hydrogen from reforming, so it isn't low carbon. There isn't huge demand currently. There is huge demand currently for hydrogen, and it's being met with fossil-derived hydrogen that's feeding into existing industries that have been operating for a long time, decades really. I think it's just important to set that context so that when we talk about demand growth of low carbon hydrogen, that I'll go on to in a second, we know that the backdrop is that hydrogen's well established. There's a hydrogen industry out there. It's just not one currently of the low carbon variety. So moving on to low carbon hydrogen, currently it's very small production. It's less than 1% or something like less than 1% is currently low carbon, but demand is forecasted to increase very significantly. Forecasted increases are driven by new applications for hydrogen mostly. So that's includes things like steel manufacture, some transport applications, energy storage, power generation in some regions, synthetic fuels, those sorts of industries. Although it currently makes up a very small proportion of overall hydrogen demand, these demands in these new sectors it grew by 40% between 2022 and 2024. So they are growing very, very fast, even though they're currently a small proportion. There's evidence that policy and mandates are starting to have an impact. There's lots of contractual agreements being announced, MOUs. So that certainly demonstrates intentions, although it's not guaranteeing demand yet. And there are many forecasts out there that are all broadly predicting an increase from anywhere from 20% to up to 60% in total hydrogen demand by 2030. So, I mean, from that 20 to 60% range, you can hear there's a lot of uncertainty in forecasts, lots of unknowns, but all are still predicting a pretty strong growth, even at the 20% end. That's quite a strong growth. As I mentioned, future demand growth is driven by new technologies, and the future of each of these technologies is quite uncertain, and that's probably one of the key drivers as to why we get a massive variation between the forecasts. There's a lot of uncertainty in which of those applications is going to be successful and scale. If you switch on and off the different new applications within that forecast, then obviously the picture changes. And the challenge is knowing firstly which ones are on and which ones are off, and secondly, how big is that demand associated with that new need. So that's kind of some description of the demand from industry and for low carbon hydrogen. I guess a point about low carbon hydrogen. So that derived from electrolysis, green hydrogen if you're into colours, or from methane reforming with carbon capture, blue hydrogen. That's low carbon hydrogen. It's anticipated that a little over half of the demand for low carbon hydrogen will be electrolytic hydrogen at around 2030. But of course, there's a cost difference between the two, and hydrogen from reforming is closely tied to natural gas prices, and so the forecast on the split is likely to change. But something like a little over half by 2030 is what's forecasted. So just recapping, the existing hydrogen industry, the current hydrogen industry, which is largely fossil fuel derived, is very big. And while low carbon hydrogen demand makes up a relatively small proportion of that, it is expected to grow very fast. But there's a lot of uncertainty. Bumps in the road for low carbon hydrogen demand could be the applications, which are deployed at large scale and which ones don't materialize. And as I say, more than half of the low carbon hydrogen demand is expected to come from electrolytic hydrogen, but that's exposed to a few things like natural gas prices and the success of deployment of reformers with carbon capture.
Fantastic. Thanks for that, John. It's absolutely important to get that context. And your opening insights there lead nicely into my next question, which is really the question that's been on many people's lips for so many years now. Mm-hmm. How do we scale up our supply chains in order to both generate and meet the demands for hydrogen?
Yeah, so scale up. So we've established that demand for low carbon hydrogen is expected to increase fast, probably significantly. And that needs a fast response from every component of the hydrogen value chain. So from production by electrolysers, and I'll generally focus on electrolytic hydrogen now when I'm talking about production, transport and storage infrastructure, obviously critical to get the hydrogen from production centres to the points of demand, and technology for end users and applications. So the new applications that I've mentioned a minute ago, for example. So each of these three components are in quite different places on their scale-up journey, or how ready they are for scale-up. So electrolysers, for example, they're growing or they're progressing fast. There are lots of large projects being announced, increasing in sizes actually, so gigawatts of scale being announced. Not yet proven at this massive scale, but they're not far off. You've got the 2.2 gigawatt NEOM project in Saudi Arabia under construction. It's due to start production, I think, end of next year. So provided all goes well there, we're close to seeing alkaline electrolysers demonstrated at the gigawatt scale. Otherwise, there are various other projects of a gigawatt and tens and hundreds of megawatt scale as well that include other electrolyser technologies. Just to touch on the other components of the value chain, transport and storage infrastructure is also making progress in a lot of areas. Plans for pipelines in Europe are making progress, and there's quite a lot of activity in exploring the different hydrogen carrier options, so LOHCs, ammonia, some liquid hydrogens being discussed as well. But some of our own research at ERM, we've found that there are significant gaps between the scale of infrastructure required to meet forecasted demands and what is actually being planned in terms of announced projects. So positive movement, probably not enough, much more scale up needed on transport and storage infrastructure. And briefly on end use cases, the applications for hydrogen, it's a bit tricky to summarize quickly because the story is obviously quite different depending on which application you're looking at. Large scale ammonia production from electrolytic hydrogen, for example, you could say it's progressing well because, again, the NEOM project is going to produce ammonia from electrolytic hydrogen. So that should be demonstrating that within a couple of years. And then that's feeding into downstream ammonia cracking technology. So we should see that demonstrated within a couple of years. Heavy duty transport hasn't yet scaled significantly, but perhaps that's, there's some other challenges there that may be associated with cost rather than technology. So really getting to how do we scale up? How do we make that happen? I think starting broadly, I think we need to scale up skills. Knowledge and understanding with electrolyzer technology there's a lot to be done there. We need engineering design practices and design practices that support scale up. So modularization and standardizing designs that can achieve those economies of scale. But one point I'll go a little bit further on. To really enable projects, we need strong collaboration between organizations on these projects. So I think the key learnings of collaboration apply more widely. So I'll just go into that in a little more depth. But engineering work processes, approaches, methodologies, procedures may not apply in the same way on very large scale projects. So if I can get kind of specific to illustrate the point, the commissioning of a single 10 megawatt electrolyzer the commissioning procedure for a single 10 megawatt electrolyzer is unlikely to be suitable for a plant that is 100 10 megawatt electrolyzers. And the skills and knowledge to produce that scaled up version of the procedure may or may not be within the knowledge base of an electrolyzer manufacturer. So perhaps, maybe that task is better suited to an EPC, an engineering contractor, or a plant operator. And if that procedure then leads to a change in design, what's the impact of that? Are there changes in equipment required? And if you do need to change equipment, how expensive is that going to be on 110 megawatt electrolyzers? And can you mitigate that risk by ensuring that you collaborate earlier on the projects? So, is it getting an engineering contractor and an electrolyzer manufacturer working together earlier to make sure that the large scale facility is considered much earlier on in that design process to try and mitigate that challenge? So scale up isn't just this thing but bigger. It's a totally different facility, with different methodologies, different procedures, different approaches. And I think the best way that you can tackle that kind of challenge is to ensure that the right knowledge is available, and that you can come through, and that can come through collaboration and partnerships and between the right organizations. So thank you for indulging me on that kind of fairly detailed example, but hopefully it kind of illustrates one of the key things that I think really needs to be applied when you're thinking about how to scale up electrolyzer projects.
Absolutely, some great thoughts there.
Yeah, thanks for that once again, John. Topics there that we'll no doubt be covering on webinars going further into the year. But finally, for now at least, with the current and future projections for hydrogen demand, do you think we could be heading towards an oversupply perhaps? We often hear about these new and larger electrolyzer projects. You mentioned NEOM earlier. So will supply start to outweigh demand?
Yeah, it's an interesting question. So I think just to put some numbers to it, I've seen some demand forecast, as I say, 20 to 60% growth to 2030 from a baseline in maybe 2022. So that's quite a lot of growth. Another forecast I've seen says 6 million tons per year of demand for low carbon hydrogen in 2030. It could be realistic based on policy support. So we could work with those numbers in terms of demand. On the production side, one forecast estimates that around 10 million tons of electrolytic hydrogen could be available per year in 2030, and I think that was based on advanced electrolyser projects or post FID electrolyser projects, or both advanced and post FID. So clearly the two don't quite match there, and it looks like there's a little bit of an oversupply, perhaps. Although if you look at the range provided by that 20 to 60% growth from now, then maybe they are kind of within ballpark. But to revisit a point kind of made earlier, that there's a lot of uncertainty, there's a lot of complexity here with the demand forecasts. Are they too optimistic? What happens if deployment of one of the applications doesn't grow as expected and the forecast needs to come down? What if it grows more strongly than expected? The demand picture changes very quickly. On the production estimate side, the electrolyzer projects, there are a number of very large project announcements, gigawatt scale projects. But we've also seen several project cancellations recently too, which indicate that even a mature project through FID is not necessarily immune to some of the challenges that are happening, and it's not certain that they'll go ahead. So and when projects are at that large scale, that gigawatt scale, there's quite a lot of exposure to the failure of one or a few projects. You lose a very large capacity of electrolytic hydrogen if a couple of projects fail. So I think looking at the strongest, most bullish scenario, let's say we're well progressed. The well progressed electrolyzer projects do all get built, and then maybe you could feasibly see an oversupply, thinking globally. But perhaps at that point you see some price movement within the constraints of the profitability of the project. But maybe some more competitive pricing ends up enabling more demand, and things balance out. So I guess just to summarize, if all of the announced electrolyzer projects go ahead, and the demand forecasts end up a little bit on the low end, then perhaps you could realistically see an oversupply of low carbon hydrogen. But I think far more likely is that we'll see some electrolyzer projects drop out for various reasons, face various challenges. Demand forecasts will be revised based on how those new technologies progress, and ultimately the two will likely find a way of balancing, whether that's by pricing or something else in the longer term.
Absolutely, thank you, John. And we do indeed see some projects running into complications very much in 2025. And on the topic of production, Tom, I have some figures here on green hydrogen from Gasworld Business Intelligence and our H2 Intelligence dashboard in particular. So right now in 2025, we see a total output of around 3,090 tonnes per day. And if we're using those dates at the top of the webinar, then this ramps up to just over 161,500 tonnes per day in 5 years' time in 2030, while 2040 sees that nearly double to 310,852 tonnes per day. That's the latest stats coming in.
Fantastic. Well, thank you for those figures, Rob, and thank you, John, as well, for your input there. It will be interesting to see if demand and supply do remain in tandem, or if we are indeed headed for a period of oversupply or perhaps shortage in years to come, especially if some of those figures that we see live up to their aggression. Don't go anywhere, John, because I'm sure that we'll have some audience questions for you shortly. I know I have some for you already. Now, we've heard about the need for increasing hydrogen production and demand, but just how do we scale up the hydrogen economy? Well, we're now going to hear from Leanne Halliday, Global Head Energy and Renewables at LRQA, to find out more.
Leanne is a chartered chemical engineer with over 22 years of experience in the energy sector, spanning design, commissioning, project management and sales across the UK, Asia and Australia. For the past 12 years, she has been with LRQA, where she has played a key role in ensuring safety and quality across the energy supply chain.
As LRQA's Global Head of Energy and Renewables and Hydrogen Subject Matter Expert, Leanne is actively involved in hydrogen projects worldwide. She also contributes to the development of industry standards as a member of various Australian and ISO hydrogen-related working groups. Based in Western Australia, she brings deep expertise and a global perspective to the evolving energy landscape.
And being based in Western Australia, we thank Leanne for joining us at this very late hour. Now, Leanne, one of the key themes of this webinar is, of course, scaling up for the hydrogen economy. And indeed, one of the key challenges facing the electrolyser business is that challenge of scale. So what is the route to increasing electrolyser capacity, and what unique challenges does this then create? Not sure if we can hear you there, Leanne.
Rookie error. I'm back now. Absolutely, and it's a pleasure to be here. Really good question, and I don't think there's a golden bullet answer. So we work with manufacturers, operators, stakeholders across the full hydrogen economy, and I guess what we see from scaling up falls really into three main brackets. So one of them is around technology. And it's technology, like Jonathan mentioned earlier, isn't new. Electrolysers, hydrogen production, been around for many years. But what we need in order to make this a commercially viable industry is we need to be a lot more scalable. We also need to put innovations into the technology, which we're seeing. And therefore, we need to get those innovations to market, and we need to get them to market quickly. So what we're seeing is a lot of manufacturers moving into this industry. So they might have worked in different sectors, now bringing their expertise, for example, from the automotive sector into hydrogen to make the production of electrolysers a lot more commercially viable through doing continuous processing rather than batch manufacturing. We're also seeing new innovations coming in to make the electrolysers more efficient, more commercially viable that way, more compact and more modular based. And therefore, it's a matter of bringing that technology to market quickly, commercially, and effectively. The second area, which Jonathan also mentioned on, is competency. We talk about this massive scale up in hydrogen, and we don't have a lot of Jonathans in the world that have come through working in this hydrogen and industrial gases their entire lives. So we need to train people, and we need to train people quickly. We're working a lot with the market in order to get people coming from different sectors, from automotive, from oil and gas, from different power sectors, and getting them to really understand hydrogen production, and also hydrogen equipment manufacturing. The third and probably the most important is the legislative landscape. And this comes from both the legislation within the technical aspect, in some cases moving more slowly than the actual projects are. So you're finding people wanting to take electrolysers or different equipment into countries that don't have the legislation or standards in place necessarily to look at hydrogen at this scale or electrolysers at this scale. So they're behind the curveball. But then we talked about using automotive principles in electrolyser manufacturing to make it a lot more scalable and quick, whereas they're working under an industrial, legislative and standards environment, which doesn't necessarily tie itself into this type of production methodology. So there's a lot of things at play. And also, frankly, we need to have support from governments in order to make these scale-ups a reality, in order to avoid us from losing this race towards the 2030 carbon emissions. Because we've got to remember that why are we doing this? Why are we talking about this today? And what's the overall purpose of green hydrogen? And it's to reduce carbon. And therefore, we need support in order to make this industry a reality.
Fantastic. Thank you, Leanne. Now, you've touched on it there, but let's go into it with a bit more depth now. Another of the biggest challenges, particularly for electrolyser OEMs, is the various regulations and standards across the entire hydrogen sector, really. So do you see this as majorly hampering the scaling up process of hydrogen, and what would you like to see happen next?
Yeah, absolutely. Good question. And like I said, it is one of the key three pillars of risks that we're definitely seeing within the market. I wouldn't necessarily use the word hampering. I would more use the word slowing down. So what I would like to see is this industry has to be a global industry, okay? But what we see now is every country, not every country, I'm exaggerating, but most countries and definitely most regions having their own take on legislation and standards. And a lot of them just taking what they take from the traditional oil and gas or power sectors and trying to push it into the electrolyser market. And therefore, companies who are producing electrolysers have to understand all of this different landscapes. And some of it can be quite trivial, but some of it can be quite major. For example, sending an electrolyser to America or sending it to Europe or send it to Australia can be quite different. And therefore, they have to go through a lot of different processes, a lot of different assurance mechanisms to make sure that their electrolyser is technical capably for each of these different jurisdictions. Like I mentioned as well, it's also a matter of production. So as we move from industrial batch production into more continuous production, some of the requirements of pressure equipment, for example, like PED, is really slowing down some of this manufacturing based on the level of documentation you need and the level of checks you need throughout the process. So there is a need to recognise the different global jurisdiction and legislations and making sure that we can streamline that a little bit. And then also looking at how do we retrofit and make sure that traditional industry legislations and standards meet this new way of manufacturing. And that's even without thinking about some of the issues within the ESG space. So like I spoke about, the purpose of us doing this is to reduce carbon. One of the big things that is hampering or slowing down some of the large scale hydrogen projects is around how are we going to actually determine how green that molecule is. And particularly when you're crossing borders, for example, if you're selling European made green hydrogen into Asia or Middle East made green hydrogen into Asia, etc. And there's that whole piece still at play about how do we actually determine how green that molecule is. So I guess to summarise, some of the legislation is moving slower than the projects. This is a global industry. We have to look at it as a global industry, but the way that legislation and standards at the moment is it's quite country or regional specific, and therefore manufacturers have to get their head around a lot of different legislations to be able to send their electrolysers globally. And then finally, we have to remember that once we produce that green molecule of hydrogen, how are we going to be able to trade it? And at the moment, there's not really that global view of that. One of the other questions I often get asked in this space is around Chinese electrolysers. So if we look at the global capacity of electrolysers at the moment, it's around 25 gigawatts, but 15 gigawatts of that is coming from China. And people often ask me about the standards and the technical capability of them electrolysers. What I say is the biggest green hydrogen production at the moment is in China. Therefore, these technologies absolutely work as an overall broad brush. But what we're not able to do is sometimes get the transparency of the levels of documentation, etc., that we need in order to prove that they are capable to be used within the European or the American or the Australian market. And therefore, this takes more effort, it takes more time, but nobody should absolutely discount these electrolysers as not being technical capable. You just might need to build a bit more time assuring them within the specific markets that you're working in.
Fantastic. Thank you, Leanne. You might just have opened up a whole new webinar for us there. We'll have to come back to that final point. Just one final question for now, at least. One more challenge, should we say, finance. We've got a webinar coming up all about that in the next few weeks. But here and now, how do we begin to tackle the challenge of financing and the financial bottleneck that the entire industry faces right now? So many projects fail to get over that FID threshold, as we all see. So what is the solution to get that economic backing for electrolyser projects and essentially de-risk them for the investor?
Yeah. Based on my experience of current large projects that haven't gone in or recent ones, one of the biggest issues is off-takers, right? You might not necessarily have the off-takers in the location where you're producing the hydrogen, or it's a bit of a chicken egg situation. But that's not what this webinar is talking about, right? We're talking about electrolysers, we're talking about legislation, etc. So I think from a technology perspective and from an operator perspective, one of the things is doing a true due diligence of the project, and not due diligence like we used to speak about, where it's just about return on investment, but it also has to have that big play about how do you unlock the finance and how do you unlock the government incentives that are available for your project. So there's that big element within the technical diligence. And then there's also the part about, we don't just have to look about this as money, but also what is the ESG impacts, right? So what difference is this going to make from a carbon trading perspective and from reducing your carbon emissions, which has to be brought in. But if we look at that unlocking finance, it's really interesting. One of the big funds that's just been announced quite recently was the European Innovation Fund, which was over 4 billion euros worth of work. Sorry, I'm just checking that figure. Yeah, 4.8 billion euros worth of funding available to the electrolyser manufacturers and operators. And one of the things that they looked at, which was really interesting, was you needed to be able to prove your social responsibility within the supply chain. So we know that some electrolysers sometimes get a bad rap because they have got precious metals in them. And how are you assuring that from a social perspective you're doing the right thing? You have to be able to show your carbon intensity and your carbon management, particularly with scope 3s. You had to show your cyber assurance and your cyber resilience, and then you had to show assurance to ISO 22734. So for me, that was one of the first funding that actually laid out all of them key areas that are not just traditional ways of looking at unlocking funding, but also some of the fundings and some of the risks that we see in today's landscape really embedded into unlocking that funding. So to summarise, I guess we look at it differently. We look at a wider view. We look at the ESG impacts. We look at why are we doing this? And we also look at what do we need to do to unlock them incentives in order to get the market up and running.
Great, thank you for that, Leanne. And if we can keep hold of you for just a little bit longer, we're going to return to you shortly during our audience Q&A. And just to remind viewers, if you have a question for any of today's panellists or you want to drive the discussion, I can see plenty of conversations happening, then please do send in those questions and comments and we'll do our best to put them to our experts. But before then, it's time to hear from our third and final speaker of the day.
That's right. We've heard about the need for scale. We've heard about the challenges and solutions. And as Tom said, we've got some fantastic conversations going on sort of in the moment right now, which is great. But it's now time to hear from someone with their boots on the ground within hydrogen production, and that is Deepak Bawa, CEO at Splitwaters.
Deepak is a results-driven leader with over 22 years of experience in the hydrogen, ammonia and methanol industries. He has a strong track record of driving growth, productivity and profitability, leading high-performing teams to execute complex business development strategies with remarkable success.
With proven leadership skills, he has navigated industry challenges and played a key role in securing billions of dollars in successful transactions. Over his career, in fact, he has developed and executed projects valued at up to $4.5 billion US, making a significant impact on the global energy landscape.
Deepak, welcome to the webinar. Thank you for joining us today. Now, first up, please tell us all about Splitwaters, your electrolyser technology, and any real-life use case projects that you're involved in.
Thank you, Rob and Tom, for the wonderful introduction. And for Splitwaters, the thing is, we believe in empowering industries with the cost-effective green hydrogen because it's a young and immature field, and people are ready to transition into low-carbon hydrogen as long as it makes sense financially, because that is the key. And for us, just to give a broader perspective first, like why we believe in green hydrogen. The hydrogen market itself is bigger than LNG market. The LNG market is $110 billion and the hydrogen market is $130 billion market dollar-wise, right? Now, gray hydrogen has been in utilization for over 100 years in like any kind of refinery. You have to hydrotreat the crude oil, and for ammonia, methanol, urea, any kind of fertilizer production, you need hydrogen. And then you have other uses also, but these are the two main uses for hydrogen. So whatever we do, we have impact of hydrogen on our life. Now, when we talk about cost-effective green hydrogen, Split Waters is a one-stop shop company which provides electrolyzers and we provide EPC services. And the thing is, right now, there are companies who will provide you electrolyzers or who will provide you EPC services, right? And that's where the problem is because every company has their own markups and coordination cost and the contingency. And then when three companies like electrolyzer company, EPC company, and then the construction contractor, if they are working together and they are putting all these costs plus procurement markup, the capex of the green hydrogen project goes really high. And that's where we come into the picture. We provide all the services under one roof. And in that way, we can reduce the capex by up to 30%, which is a big number for, say, gigawatt scale projects, right? And that's where we empower our clients to go FID for these green hydrogen projects. And not just green hydrogen, we provide solution for the e-fuels also, whether it is e-methanol, green methanol, or green ammonia, e-SAF. And that's the key. We have our alliances with Topsoe, which is one of the top technology company in the world for oil and gas. And we have partnered with Turner Industries, which is one of the top construction contractor in United States. And we build our electrolyzers with them. So in that way, we can keep our cost really low and we can offer a solution, not just green hydrogen, but the e-fuel plant also. So if somebody is building an e-methanol plant, we can do all the engineering, procurement, construction, commissioning, startup of the green hydrogen section, as well as the e-fuel part, whether it is green ammonia or e-methanol. Right now, we are doing projects all over the world. We started last year. We are a very young company, but we we have engineers who have been working together for last 45 years, right? We have that team who we have 250 engineers in US, UAE, and India, and they have been working together for 45 years. So it's a well-oiled machinery who have tackled so many complex projects, and now we are dealing with the green hydrogen and e-fuel projects. And I believe this is the strategy which is required in this market. And all the clients have given us a warm welcome. And that's why we have projects in Europe, we have projects in US, we have projects in Western Australia, and we are doing 5 e-methanol projects in India. We are trying to play our significant role in this energy transition and trying to help the clients to bring the capex down and boost the IRR so that they can go FID.
Brilliant. Thank you, Deepak. Now, one of the questions we set out to find out on this webinar was if developers will start to invest in newer systems, perhaps, such as fast evolving technologies like SOEC and AEM, or if they will likely continue with PEM and alkaline technologies. So, of course, with the asterisk or the caveat that you are deeply invested in alkaline electrolyzers, what would your thoughts be on that question?
Yeah, Rob, that's a very good question. And, like I said, this is a young and immature market, right? We have one of the oldest and proven technology as alkaline electrolyzer technology. And it has been in chlorine manufacturing for last 70 years or so. So people know that it works and it provides the results which it claims. And that's why we provide that alkaline electrolyzer technology to the world. PEM electrolyzer technology, yes, it has its own place, it has its own uses where the plants are small, where it is more fluctuating power than consistent. And then we are talking about these new technologies like SOEC or AEM. But if you are an investor, you want to invest in a project where there are not many technological challenges, you have the right offtake and you have the right capex so that your risk metrics is very small, but your IRR is there, right? And then only people put money in these kind of projects. What we believe at this time, alkaline is the most proven and most trustworthy electrolyzer technology out there. And we are working on the side on the newer technologies. I don't want to spill the beans in this webinar, but I think in next 3 to 5 years, we will be coming up with other technologies where investors will have confidence, because by that time, these technologies will have a longer run time, like for 6 months or 1 year, that this is the degradation curve and this is the efficiency which these electrolyzers can produce. But for now, whatever we have seen in the market, the moment people go above 100 megawatt project, they want to stick mainly with alkaline, and in some places they want to stick with PEM electrolyzer. And as you know, like we have so many announced projects, and given the history of these kind of announcements, we know how many of them can get built. What our focus should be that we need to offer that kind of technology, that kind of pricing, and that kind of operating OpEx where investors can feel confident and they can invest in these kind of projects. Because more than announcement, we need the FID news. So whenever I read any FID news, I'm happy, even though it is not Split Waters or somebody else. I know that, okay, yeah, we are going in the right direction. We are going to make green hydrogen. So for me, I would say today, alkaline electrolyzer is the technology to go for, and then PEM at certain places. But AEM and uh, SOEC will come into the future, maybe in 3 to 5 years at least.
Fantastic. Thank you for that, Deepak. And I can, in fact, see some questions coming in about selecting the correct electrolyzer, so we'll get into that shortly. But finally, from me, a running theme of this webinar is how do we continue to scale up hydrogen production via electrolysis, as well as the entire value chain, I guess. So how do you see this from your point of view?
Absolutely. So the thing is, I would say more than hydrogen, we need to focus on what is the use of hydrogen. And hydrogen itself is not a newer market, right? We have been utilizing gray hydrogen for a number of years. And that gray hydrogen concept has been whether it is being made over the fence model, like you make the hydrogen where it is being utilized, because hydrogen is one of the most, I would say, one of the lightest molecule on this earth. So transportation kills any hydrogen project. The other example is if you have a hydrogen pipeline, right? And then you can transport it to make something, whether you are sending it for hydrotreating the crude oil, whether you are trying to make any ammonia, methanol, urea, or something else. So for scaling up these kind of system, I would say hydrogen is like salt in the kitchen. You know, when you make salt, it has its own value, but when you make a good recipe with that kind of salt, it has a much better value. So for example, if you are making e-methanol from a green hydrogen, then that is gonna make the business case much stronger than the green hydrogen project itself. So when you talk about scaling up these kind of projects, we need to have offtake agreements, first of all, for these molecules, whether it is green ammonia or e-methanol. And we see a lot of demand out there. People say that demand is not there. I would say not, that's not true. If you are offering the molecule at the right price, there is demand. We are building our own 5 e-methanol projects in India, and there is demand. The second thing is you have to have the right subsidies, right government support all over the world, whether it is Europe, US, Asia, or Australia, because these projects are dependent on the renewable power. And we all understand renewable power can make or break this kind of e-fuel or green hydrogen project, right? So we need to have subsidies to make this energy transition a little easier. People say that why to give subsidies to green hydrogen or blue hydrogen and all that. I would say all these oil and gas companies, all these oil and gas businesses have been enjoying the subsidies for a long, long time. All the EVs have been enjoying the subsidies, because other than that, you cannot make this transition. And that is the demand of the hour, that you give these subsidies to support this energy transition. And 10 years later, we might not need any kind of subsidy once we have transitioned into green hydrogen market. So for scaling up, I would say, first of all, we need to have the right kind of projects, whether it is e-fuels or something else. And then the subsidies have to be right, whether it is Asia, Africa, Middle East, America, or Europe, right? To me, these projects can go forward as long as they have the right business model. As long as their IRR is above 15%, people will put the money. Otherwise, scaling up these kind of project would be really hard. I mean, like, I think we all understand nobody want to invest in a project where the IRR is less than 10%. And that is our goal as Split Waters. Whatever project we take, we think from the client perspective that, okay, is it making sense for them? Are they really convinced about this project? And we help our clients with the development of the projects, finding the right site and finding the right offtake. We help them because, again, we have the connections and we want to see these projects going FID rather than just announcements.
Absolutely. Well, thank you once again, Deepak. And our all-important audience Q&A is just around the corner, so we'll return to you shortly. And while those questions are being sent in, let us tell you about some of our upcoming HGV webinars.
Yes, we have a busy year ahead on the webinar front and tackling some of the biggest issues and challenges facing the hydrogen industry today, some that we've covered already. Throughout April, we'll be looking at finance and accelerating projects from concept to FID on April 4th, while on April 25th, we'll be exploring large-scale projects and the road to full-scale hydrogen deployment.
Both very fitting themes and ones that should lead nicely off the back of all of this discussion today. You can register for those for free on gasworld.tv, and we will also be revisiting the theme of electrolysers later in the year too. These are always among our most popular webinars of the year, and there are sponsorship opportunities available for that webinar to put your company in front of hundreds of viewers, hundreds of engaged viewers as well all around the world. If that's something you want to explore, please do get in touch with our sales team today or contact our head of sales, Johnny Ridd, using the details on screen.
Yes, a great opportunity, and today's webinar has well over 500 registrants, and we can expect a similar number later in this year too. So shall we take a quick break?
Let's take a break.
Are you a gas distributor, plant manager, franchise owner, or operations manager? Do you work around hazardous gases such as carbon monoxide, carbon dioxide, hydrogen, ammonia, methane, or argon? Meet the MSC2 CO2 meters fixed multi-gas detector, your industrial gas safety solution. Feel confident knowing your staff, employees, and establishment are protected when working near hazardous gases. Don't wait until it's too late. Shop the MSC2 fixed multi-gas detector today at co2meter.com.
Welcome back, and it is now time to get into all of those questions, and there is still time to send yours in, so please do make sure to submit that and avoid disappointment. But first off, I'd like to put a question. I think I'm going to put this one to John, actually. Forgive me for a moment, John. I'm going to do my sort of Nick Robinson on BBC Radio 4 moment. If I was to say, look, we've been talking about skills, knowledge, awareness, policy for the best part of 5 years, quite consistently as well, just at HGV alone. We've been doing this for all of that time. So have we dragged our heels in places? Have we sort of lost time or ground somewhere? Why do we still have such a mountain to climb?
Yeah, that's really interesting. I think 5 years is a long time, and it feels long. But the reality is that these things do take a really long time. We're trying to develop a lot of skills we're developing this new technology in terms of production. We're trying to develop the new infrastructure needed, storage. There's a lot there that's needed, and there's a lot of ground to cover. So yeah, 5 years is long, but I think these things do take a very long time. have we been dragging our heels? Is there something more that we can do? I mean, personally, I wonder if there's a way of attracting skills across from maybe the existing industries, where you could see applicability and take those skills from industrial gases or oil and gas and bring those into electrolyzer projects. And maybe there's a way of attracting that knowledge, and maybe that gives a bit of a boost to the industry and helps things move a little faster. But yeah, I guess just returns my point that it feels long, but it is a long road, and we've got a lot of work to do. And although we want to move faster, I think there just needs to be that kind of that reality check that these projects are huge, and they're complex, and there's a lot to learn, and that takes time.
Certainly, thanks, John. And Leanne, I could sort of see you smiling and nodding off camera a little bit there, and I just wonder maybe you'd like to add something to this.
Yeah, I did have a really good point here. So I just recently was involved in a global survey from a recruitment firm. And actually this year they did see an actual move back from people wanting to and actually working in renewable projects, moving back to traditional energy projects. So I guess what we've got to remember as well, we've got all of these exciting hydrogen and renewable projects going on. We're also in a context globally where we've got an overall increase in overall energy demand. And therefore, we are seeing oil and gas projects going ahead globally, and they are still taking a lot of the talent. And therefore, we talk about 5 years not being a very long time in the context and needing a lot of them expertise. But also, we've got people and even new entrants from new graduates coming in that don't necessarily want to go straight into this industry, but want to cut their teeth on oil and gas, or want to actually move back to oil and gas projects because that's where the work is, and frankly, that's where the money is as well in some aspects. So yeah, it's a bigger context there I think we're working in.
Absolutely, thank you. Up against a number of challenges, clearly.
Yes, thanks to both of you for that. Deepak, I'm going to come to you with our first audience question from Andrew. And Andrew would like to know, what is your view on project risk in reference to risk from coupling two large industrial processes together into a new mega project? Gives an example of green hydrogen to green ammonia, green hydrogen to eSAF, etc. What would be your thoughts on that?
Yeah, interesting question, actually. So we get this kind of question a lot, especially from the investors. And the thing is, we need to understand ammonia loop technology has been in utilization for over 100 years or something. So that part is kind of taken care of, whether it is we are talking about methanol or ammonia, that technology is proven. On the left-hand side, when we talk about the green hydrogen, alkaline electrolyzer has been in the market for over 70 years, and we know that this technology works. And that's the reason most of the investors actually believe in this technology than anything else. Because again, if somebody is investing, say, $500 million into a green ammonia or e-methanol project, they want to make sure that this project is going to work. They are not putting their money into a science experiment. And that's why we have the partnership with, say, Topso, which is one of the top technology company for this e-fuels, whether it is methanol, eSAF, or green ammonia. And on the other side, on the left-hand side, the green hydrogen side, we are using alkaline electrolyzer technology, which we know that, okay, this is the most trusted and proven technology. So to de-risk a project like this, we need to come up with a solution. We cannot just demand from the investors, just put the money because we are coming up with a brand new technology, and you put $500 million and let's see if it works or not, right? So that's why we need to stick with what works and work on smaller projects to prove the brand new technologies. And 3 to 5 years, when the brand new technologies come into the picture and they have a lot of operating hours behind them, then definitely investors will be motivated to put their money into those projects also, right? So I would say investors don't want to put money in the science experiments. So let's say in that way.
Thank you for that, Deepak.
Yeah, thanks, Deepak. And I'm going to come straight back to you. We've got a great conversation that's been going on in the in the chat window while this webinar has been live. And the questions kind of coming up on that note of what you just said, can e-fuels or SAFs help to kickstart green hydrogen markets?
Absolutely, absolutely. And that's where the catch is, because if somebody is trying to make only green hydrogen, they have to first understand what is the application of that green hydrogen, whether it is going to go to a refinery to hydrotreat the oil, whether it is going to go to any fertilizer plant or e-fuel plant to make green ammonia, e-methanol, green methanol, e-SAF or something, because those molecules are much more profitable than the traditional, say simple green hydrogen. For example, the gray methanol goes around like $450 or $400 per ton in the market. When you talk about e-methanol, that goes anywhere from $800 to $1,100 per ton. And that's where the profit is. That's what makes a project go FID. Otherwise, it'll be challenging if the IRR is lower than that. It'll be challenging for investors to put the money. So I'm always going to think from the investor and client perspective first before offering our solution to them. Because for them, they can take any solution as long as their project makes sense. So e-fuel is the way for energy transition. We don't need to talk about hydrogen cars or any other hydrogen use at the moment. We need to first replace the gray hydrogen with green hydrogen. And then once we have spent, say, 5 to 10 years replacing the gray with green, then we can think about other uses of green hydrogen. So that's why I never debate on EV versus hydrogen cars or something like that.
Thanks, Deepak. Brilliant. And John, I'll come to you here. Is this something that comes up in ERM's analysis of the markets?
Yeah, I mean, we often work with different. We often look at the different demands and how big we expect them to be, whether it's whether it is transport, e-fuels, and we've seen a lot of movement in those kind of estimates in the last year or so. And I mean, if you take it down to economics, we know that very large volume projects are just more attractive at the moment. They're just easier to get projects started on. So that is things like e-fuels. Transport is a real challenge. The cost of the fuel is very high, and of course you're competing with battery technology that is just very, very effective in that environment. So yeah, for sure, I think what we see certainly echoes a lot of what Deepak has said there, for sure.
That's it. Thank you. Now, also among this conversation that's been percolating in the group, we've got this observation that actually oversupply might not be a bad thing, and the view that this could help with customer acceptance and ultimately cost matters. And I think we've got a question to that effect, haven't we, Tom?
Yes, we do. Jonathan, I'm going to come to you on this one, and Leanne, I'm going to open it up to you as well. But first, John, given the potential for oversupply in 2030, as we've just referenced, what's going to bridge the gap between projected supply and that uncertain demand? Is it going to be competitive pricing, policy incentives, or something else completely?
I mean, probably a combination of a few things. I would expect, but I think I touched earlier on it. Pricing certainly, and price I think comes out high for electrolytic hydrogen at the moment because there's little of it, and those that there are some sectors that need it, and so the producers know that they can charge a certain price for that. If we move into a place where there's an oversupply and there's lots more available, then it's a lot more competitive landscape, and you can start to expect that prices get driven down, and as you kind of commented on, that's not a bad thing, because maybe if the price is starting to come down, then you unlock more demand, and you're just moving into sort of a more kind of functional market in that way. So yeah, I certainly think that pricing is likely. I guess the one challenge to that is that you still need to be within the realms of profitability for your project. So you've always got those constraints. So yeah, you can only drive the price down so far and still be viable. So there is that challenge. But yeah, I think I certainly think pricing is pretty key.
Thanks, John and Leanne, to open that up to you as well.
Yeah, I guess the only thing I would add to that is one of the issues we were seeing a few years ago was that the availability of electrolysers was slowing down some of the investment and actually having access. So there was one project that I worked on where they had to put an order in for an electrolyser 3 years in advance to when they needed it. And also they didn't have the options of electrolysers out there in terms of the technology, therefore they just had to get what they were given. So it's not just about the competitiveness, but it's also the availability that drives the different project dynamics and makes it a lot more feasible, I guess, in terms of the FIDs.
Sure. So that's look forward to 2030, but here and now in 2025, that's still 5 years away. So a question from Andreas is quite a brash question. Do you expect electrolyser manufacturers going bankrupt this year or in the next 5 years? Is it a tricky market?
Seen a immediate slowdown of electrolyser manufacturers. So that's definitely something we've seen the back end of last year and the beginning of this year. I wouldn't necessarily say there's a stop, but it's definitely a foot off the accelerator, and also looking at their areas of production, looking at low cost areas of production, for example. So there's a change, but I would say it's a stall. And if we look at, like we've talked about throughout this webinar, the market's still there. It might not be the massive gigawatt projects being announced, but even to just decarbonise the current industries, the market's still there. So I think it's just a lull. We're seeing a lot of political upheaval at the moment. People are pushing back investment based on that. So yeah, there's definitely a stall, but not a stop.
Thank you, Leanne. And Deepak, as Rob said earlier, your boots on the ground in the hydrogen electrolyser business. So I suppose, is the cream going to rise to the top?
Yeah, so very interesting question, actually. So I have a little different opinion on this one. The electrolyzer manufacturers, I would ask the question, how many of the electrolyzer manufacturers are posting profits in last couple of years? I would say most of the electrolyzer manufacturers are in red. And I'll be very honest, if you are selling a product, not a complete solution, but a product, and if somebody buys that product and it does not make that CapEx sense or IRR sense, how would they buy from you, right? The project has to make sense, even though you're trying to sell your product. So based on 2024 and 2023 financial results from different companies, we are hearing news from different electrolyzer manufacturers. They are kind of doing the replanning, that how they're gonna rearrange everything to cut the cost, how they're gonna lay off the workers, how they're gonna decrease their capacity on all that. Because I would say we need to think about a complete solution to the client for them to go ahead with FID. The announcements are not gonna kind of help surviving this market. I think in this year we're gonna see a lot of consolidation and lot of people going out of the business completely, because people thought that there are huge subsidies and we can sell that number of electrolyzers. But that's not true. Projects have to make sense. Only then people gonna put money and the project's gonna go forward. So for electrolyzer manufacturers, I would say yes. Many of them, if they keep putting the losses in front of their investors, yes, the day is not far. They're gonna run out of money, and some of them will go out of the business. And to be very honest, it happens in all kinds of industries, whether oil and gas or EVs or anything. You will see these kind of examples everywhere. You have to have the right business model to survive in any industry, and same is true for green hydrogen industry.
Thanks, Deepak. Some interesting points there.
Yeah, absolutely. And I'm going to come back to Deepak and then perhaps Leanne as well. Our viewers are also noting, among the many challenges, the intermittency of renewable powers such as wind and solar. In fact, Blake Putney says nobody seems to be talking about the cost of energy. It seems like low cost energy equals inherently intermittent as well. What can we say about this whole stop-start with electrolyzer technologies and that inherently intermittent power that it relies upon? Deepak?
Yeah. So very interesting point. Again, this point is coming from when people start thinking about going FID on the project. Because if the power is intermittent, obviously the power can be cheap. And if you are not putting BESS, battery energy storage system, then you are operating whenever the power is available. So sun is available, say for 8 hours or 12 hours somewhere, and then you have wind for a few more hours, but maybe 6 to 8 hours, you don't have any power on the day. At that time, if you are shutting down your electrolyzer, doesn't matter whether it is PEM or alkaline, it's going to impact its health. You can you can use the electrolyzer from 100% to say 60% easily without any impact on the life of the electrolyzer. You can do that, but don't think that it's a gasoline car or a diesel car that you can turn it on whenever you want or turn it off whenever you want. Technically, you can put it on hot standby and then you can again ramp up in less than 3 minutes or something. Technically, you can do, but you are impacting the life of the electrolyzer. What I would suggest is whatever projects we are doing all over the world, what we suggest to our clients, we have a kind of a detailed business model or a detailed project model where we tell them if you want to produce that much of green hydrogen, you need that kind of solar plus wind plus BESS, right? This kind of system, which makes it close to say 95% availability or more, because that's where project is going to make money. If you are running an electrolyzer, say 70% of the time, project is not going to make money. And I would say hardly that kind of project can go FID. If it is 5 megawatt or smaller project, yeah, that can go. But if you're talking about 100 megawatt or bigger projects, they need to run as much as possible, close to 24/7.
Fantastic. Thank you, Deepak. And Leanne, just very quickly, you've got more than 22 years experience in this energy sector across various geographies where I'm sure, in fact, between where you are now and where you've lived previously, you've got different experiences of wind and solar intermittency. Your thoughts?
Yeah, and it's looking at the full ecosystem. And I'll go back to one of the points I brought about how green is that molecule that you're producing, right? Because that's where a lot of projects fall down. And Jonathan, you mentioned the colours earlier, and we get into it, how green is green? So what shade of green is it? And this is where we get to about the electrolyzers and the intermittency of power as well, because sometimes you might have to rely on some grid power coming in and where you don't know where how green the power is. And therefore that affects how much your green molecule at the end of the day is worth. And that's why that carbon management and that carbon and hydrogen certification at the back end is really important and feeds into the whole FID decision, and whether these projects are going to be worthwhile or not.
Absolutely. Thank you, Leanne and Deepak.
Yes, thank you for that. Now, John, I'm going to come to you with another audience question here. Returns to what we spoke about earlier a little bit, but they would like to know what the hydrogen supply chain looks like and what the bottlenecks currently are at the moment.
So, so do you mean in production in electrolyzers and what is the challenge there?
It's holding up the development.
Oh, sorry, the audio didn't work there.
Yeah, but the supply chain behind electrolyzers, I'm assuming, is what Mies is referencing.
Yeah. Oh, okay. Well, so I think it's tricky because it depends on the electrolyzer technology. So the supply chain behind PEM electrolyzer, you might be looking at rare earth or your critical materials, your platinum group metals, PGMs for core components, and that's receiving a lot of conversation at the moment, and how we go about getting access to those materials in an effective way. For alkaline electrolyzers, I think specifically it's less constrained. You know, the supply chains are already well established, and they're using generally more equipment that's fairly typical or fairly standard. I'll let Deepak correct me on that if I've said anything wrong there. And then if you look at AEM and solid oxide, then the challenges are actually different. You know, they're at a lower maturity, and so you've got innovation there that's slowing those down, or you know, just time taken to develop those technologies that's perhaps slowing those down a bit. So I think, you know, the bottlenecks for each technology are slightly different.
Great, thank you, John, and hopefully that's answered Misa's question.
Yeah, hopefully. One final audience question. There's been a lot of conversation around materials for electrolysers as well. I mean, we often see this. But I thought we could use Luca's question as the final one in terms of turning this around from the challenges and what we can do driving forward on a more positive footing. So Luca asked, what technological developments are needed to make electrolytic hydrogen cheaper? Are we looking at innovative materials, innovative designs, or simply a larger scale of production? Perhaps we could do a round robin here. John, we'll start with you.
Yeah, sure. So as is often the case with this sort of question, it's you know, a combination of multiple things would be very valuable. Certainly improvements in materials to drive increases in efficiency is very important. Efficiency is obviously key, particularly in markets like Europe. If you want to operate an electrolyzer where the electricity is super expensive, then efficiency is extremely important. If you're operating in an environment where electricity is less expensive, then you know it's kind of got a different priority. So yeah, I'll focus on that and leave others to the other participants. But so technology innovation in materials and components to drive efficiency increases.
Fantastic. Thanks, John. Leanne, I'm going to come to you next. It must be almost midnight, so it seems unhelpful to keep asking you questions. What's your take on that?
I completely agree with Jonathan, and I think it's a mixture of them all. The other thing that I don't think we've talked about, though, is the balance of plant associated with the electrolysers. So the compressors, the pressure vessels, and that comes where we talked about the increase in overall energy demand. So you've got all other sectors fighting against the same supply chains. So that can sometimes have an issue, particularly if we talk about the compressor market looking at doubling in size over the next 10 years, if we look at the scales of the investment. And then secondly, the glass reinforced pressure vessels, which really plays into hydrogen and the storage of hydrogen, and there needs to be big innovations in them as well in order to make it a successful and scalable, efficient market.
That's it. Thank you, Leanne. And Deepak, your final thoughts on what technology might be required?
Yeah, so let's keep things very simple, right? It's already a young and immature market. If we expect too much, maybe things are not going to work out. So two things. First of all, power utilization. We all know that green hydrogen needs renewable power. So if we can be efficient in the use of renewable power, that's what clients need. Our electrolyzer already takes 49.28 kilowatt hour to produce 1 kilo of hydrogen, right? Competition is at 51 or higher. We are trying to hit 46 kilowatt hour to produce 1 kilo of hydrogen by the end of this year. This is exactly what is required in the market, that they need kind of a better usage of power. Now, as Leanne said, it is not just about electrolyzer, it's about balance of plant also. So when a client is looking at a plant, he's looking at the whole thing, not just electrolyzer. And electrolyzer is a small piece of puzzle. What I would say is the total installed cost, that's where the catch is. Even if somebody buys electrolyzer cheaply or the balance of plant even cheaply, they have to work with an engineering company, construction company to commission, start, and all that. The TIC, the total installed cost for the projects, as per today's numbers, whatever I have got from, say, other companies, data analyzing companies, In US, it is between $2,000 per kilowatt to $3,000 per kilowatt. Same thing in Europe. Europe is $2,500 per kilowatt to $3,000 per kilowatt. As split waters, we are already between $700 per kilowatt to $1,500 per kilowatt. So for example, 100 megawatt plant, it was being built between $200 million to $300 million. And our price is $150 million, and we can go down to much lower number depending on the size of the project. This is where the market needs to be. That's where we can go towards this energy transition. We need to hit these numbers, and we are already providing those kind of numbers to our client, and that's what making our life easier in this industry.
Fantastic. Thank you, Deepak. Thank you, Leanne and John.
Yes, thanks all of you for that. Now, I'm very conscious of the time here, so I think it's time that we start to wrap up this webinar. So many audience questions, and it's a shame we couldn't get through all of them, but we'll be following it up after this, won't we? One final question from me, though. We're here today discussing electrolysers and scaling up the hydrogen economy. So what would be your concluding thoughts on this webinar, your final thoughts and your message to our audience today? Leanne, I'll come to you first.
Don't be disheartened. I talk about it being a hype to reality. And I think we've lived through the hype phase. We're now in the reality phase of what hydrogen can actually do to decrease the carbon output, and just focus on competency, technology and legislation, and understanding the risks in each of them in each of the different markets to be able to get a product that will meet our demands.
Thank you, Leanne. And Deepak, your final message of the day?
See, I would say market is going to filter out the players who don't have the right business model or the right mindset. And it happens in every industry. So I would say hiccups in green hydrogen industry right now, and it's going to continue this year. But we know that we are heading towards this energy transition. We're gonna get some bumps, but this energy transition is bound to happen, and green hydrogen is the rock star of this energy transition. And I would say the serious players gonna survive and thrive in this green hydrogen industry.
Thank you, Deepak. And John, finally?
Yeah, I guess echoing kind of what's been said is probably what we're going through now. Some of the challenges are very natural, and we've got to just focus on the things that we know, and to repeat something I said earlier, I really do believe in collaboration between the organizations that are working on these projects, and making sure that we really share that learning between the organizations and use that to drive forward the projects.
Fantastic. Thank you, John. And sadly, that is all we have time for today. Our thanks once again to Jonathan Long of ERM, Leanne Halliday of LRQA, and Deepak Bauer of Split Waters for their time and insights today. Thanks too to our sponsor, CO2 Meter. If you missed any of today's webinar, do be sure to go back and watch on demand. Subscribers to HTView can do just that at gasworld.tv, where you'll also be able to view our back catalogue of HTView webinars. All 59 of those are available on demand.
Wow, and we'll be back here with our next HTView webinar, number 60, as we said earlier, on April 4th, with a webinar dedicated to finance and accelerating projects from concept to FID. To register for that for free, visit gasworld.tv.
Of course, you can visit H2-View to stay up to date with all the latest news in the hydrogen industry, as well as various recaps of this very webinar. And also, why not check out our podcast, the 1895 podcast? We're in a real period of hydrogen discussion and interviews at the moment, aren't we? So just search the 1895 podcast wherever you get your podcasts.
Absolutely. And now our final thanks of the day, as always, go to you, the viewer, in homes and offices around the world, for both watching and participating and driving such fantastic Q&A. Until next time, it's a goodbye from me.
And a goodbye from me.
Announcing CO2 Meter's new gas equipment service offerings. From expert device maintenance and certifications to virtual consultations and in-depth safety training, CO2 Meter is making it easier than ever to ensure compliance and a gas-safe culture in your establishment. Whether you're protecting employees, customers, or meeting compliance standards, we have everything you need to ensure optimal gas safety in your facility. Visit co2meter.com to start your gas safety services today.